All right, so this is the last assignment for gravitation, because gravitation was, well, pretty short. Okay, we didn't need to spend all that much time on it. All right, I think this one will end up being a lot like the circular motion one, that you'll like get it mostly done probably today in class. I would think like very close, if not completely done. It's relatively short in terms of how hard any of the questions individually are. Okay, so again, just make sure you look at things like the point values for each question. Okay, there may be some questions that have two possible ways to solve them, and then of course either one would be worth full marks and would arrive at the correct answer. So if you're looking at a question, you're doing it one way and a friend is doing it another way, and you're both getting the same answer, okay, well, you're both doing it right. Okay, there are a couple of questions here that you can do in using more than one method. Okay. So just like I say, read them carefully. Okay, like number one, there's nothing really tricky about it. We're given the distance Jupiter is from the sun, and we're given its mass. We're looking at the force of gravity between the sun and Jupiter. Okay. Number two, they tell us how long it takes Uranus to circle the sun. Okay, so they're giving us the orbital period. They're telling us its mass, and they're looking for us to find Uranus's orbital radius. There are two ways to do that question. Okay. Then they give us one here about Venus. Okay, its orbital period is 225 Earth days. The distance between the Sun and Venus is given, okay, in meters. And what's the orbital speed of Venus? Again, another question you could probably do two ways. Number four is asking about an apparatus like Cavendish. Remember, Cavendish had the torsion balance. It had the two lead spheres that were fixed, and then it had the two little pith spheres, okay, that would be attracted to them, right, due to the force of gravity. It allowed them to calculate the universal gravitational constant, right? It's just saying you have a setup like that. Here's the masses involved. Calculate the gravitational force between them, right? And that's another thing to watch for, guys. Make sure that if a question is asking for force, you give force. If it asks for field strength, which you'll run into later on in here, okay, then make sure you calculate field strength. Remember that force and field strength are not the same thing. Okay, for number five, again, looking for the gravitational force between two electrons that are 1.00 meters apart, okay, is 5.54 times 10 to the minus 71 newtons. Find the mass of an electron. Okay, just as a hint, all electrons have the same mass. Okay, you're dealing with a question that has two electrons, and the electrons are all identical. They have identical masses. Okay. Number six, we've got one about a moon orbiting Saturn. We're given its orbital radius and its orbital period. We're looking for the mass of Saturn. There's only one way to do that one. Okay. Question number seven, we've got Apollo 2's orbit around the moon. Okay, it was adjusted to 111 kilometers. Okay. Is that the height above the moon, or is that the distance to the center of the moon? No, that is the distance from the surface. Okay, the moon is more than 111 kilometers. Yeah, but okay, just so you know, that's an altitude, because it never really says that anywhere in the question. Okay, it never really says that that's an altitude or a height. That's an altitude or a height or a distance above the surface or any one of those things we talked about. Okay. Then it tells us the radius of the moon is 1,785 kilometers. Okay, that's in there, but sometimes people don't really notice it. Okay, they give us the moon's mass as well. We're looking for how many minutes it takes to orbit the moon. Make sure you give it in minutes. The question is asking for minutes. Okay, you might calculate this in seconds, but they want it in minutes.
So with the 4 pi squared that formula, it always calculates the period in seconds.
Yes, it does. Okay, for number 8, we have a spy satellite orbiting at 2 Earth radii. By the way, it never outright says this, but it's orbiting Earth. Okay, I've had people who did this question thinking the spy satellite orbited other things. We don't need to spy on anybody else, just ourselves. Okay, so it's orbiting the Earth only. Okay. Well, we have lots of satellites there, but they're not like technically spy satellites. Well, yeah, it's much easier to hide the presence of alien life on Mars if you're a conspiracy theorist. Okay, using that, yeah. All right. So question number 9, we got a question about Mars and its 2 moons. Okay. Again, it's just like it's satellite motion. All right. So make sure you're looking at that one. Number 10 is the toughest question on here. Right. So a couple of hints about number 10. First off, all of these masses around the outside of the square are 1 meter apart because it's a square. Just so you know, though, the distance from here to here is not 1 meter. I have people do that all the time, and I just question their geometry, so I'm pointing it out. Yeah, all these sides are 1 meter, but the distance from corner to corner diagonally is more than 1 meter. You will have to calculate that. Okay. The other thing here is this is going to require vector addition. Okay, you will have to do some perpendicular tail to head kind of stuff for that question. So just keep that in mind when you are calculating your gravitational forces. You will have to do some vector addition. On mass 1, yes. So you're calculating the net force on mass 1 due to it being pulled by mass 2, by mass 4, and by mass 3. Yeah. Okay. And then number 11, another satellite question, could be solved more than one way. Number 12, we are looking for acceleration due to gravity in 12A, which can also be called field strength, gravitational field strength. Okay, so that can also be called gravitational field strength. Okay, and then 13, we are looking again for the force of gravity between the two masses in that question. Okay, any questions on those? Okay. If more questions come up while you're working, you can come up and ask, but again, it's an assignment, so I'll be a little bit cryptic in my answers. All right, I'll come up with a due date here in a couple minutes. All right, have at it there, guys. Okay, guys, good question just came up here, and it has to do with question number 8. It says here that the SPY satellite has an orbital radius of 2 Earth radii. That is an absolute or counted number. It does not affect your significant figures. Okay, it was given to you as a factor, right? Not as a measured value. So factor cannot affect your significant figures. Okay, so your significant figures are definitely not 1 for that question.